Okay, so the first question says that there's 1 mole of BrCl which is placed in a 2-liter container, and we have to use ice table to determine its equilibrium concentration. And given the formula and the K constant, we have to reverse it into BrCl in the initial reactant side because we only are be given a BrCa in the beginning, and we can find its initial concentration by dividing 1 mole with the volume, which is 2L, and we get 0.5 mole 0.5 m of initial concentration. And then the products of Br2 and Cl2 are 0 because there's none in the beginning. For the change, we can just use x because we don't know its value. We can just use x. It's gonna minus x of any molarity. And then for the product side, because the mole ratio is 2 to 1 or 2 to 1, therefore you're gonna get like half of x for both of the product side. But in equilibrium concentration, the concentration of BrCl is 0.5 minus x, and then for the products it's gonna be both are half of x, and so we have to plug it in. Forgot to mention that we also have to reverse the K value to 1 over 25 because you're reversing the whole solution. And just plugging them into the equilibrium to the K constant formula, we can find that x could be equal to 0.143 or negative 0.333, which is rejected because you can't have a negative value in this. And so therefore x is equal to 0.143. And then to find the equilibrium concentration of BrCl, we have to minus 0.5 of the value we just got. And so therefore we get 0.357 of equilibrium concentration for BrCl. For the second question, we get that AgCl is in 0.1 m of CaCl2, and we have to determine its solubility. And given that its constant of solubility is 1.8 times 10 to the power of negative 10, we can just let x be the solubility of AgCl in the 0.1 m of CaCl2. And then the constant of the solubility of AgCl is 1.8 times 10 to the power of negative 10. And because these two have the same mole ratio, they're gonna be x squared equal to this part because it's gonna be the same. And to add it in the CaCl2, there's extra chloride ions in the CaCl2, so therefore we have to add extra stuff in the chloride concentration. And then you can find the extra concentration of chloride from 0.1 m and multiplying by 2 because the mole ratio is 1 to 2, and therefore with 0.1 times 2 which equals to 0.2 m, and then we add it to the x. So this part is the Cl when AgCl is in CaCl2. So the chloride ion in AgCl also add into the chloride ion in the CaCl2. So these two combined each other and to get its solubility. So now its formula is equal to x, which is the concentration of silver ion, and 0.2 plus x is the 0.2 comes from the chloride ion in CaCl2, and the x is from the AgCl, and then it is equal to 1.8 times 10 to the power of 10. And from using an ice table perspective, we start off AgCl with initial concentration of x because we don't know its solubility, which is X. And then the ions are 0 because none of them have uh, happened anywhere. So for the change, because AgCl is going to dissolve in CaCl2, it's going to minus X. So it's going to be 0 for the equilibrium. And for the change of the two ions, they're going to add what the AgCl have left. So both of them are going to add plus X of the concentration. And for the end, equilibrium concentration, silver ion is going to get X, and the chloride ion is going to get X plus the 0.2 m from the CaCl2. And then we can just find X through the constant of solubility, and we can find X is equal to 9 times 10 to the power of negative 10, or if it's equal to negative 0.2, which is rejected because you can't have a negative value in the concentration. So X is equal to 9 times 10 to the power of negative 10, and it will be its solubility of AgCl when it is in the 0.1 m of CaCl2.